Okay. Now on the second application, we will take a question. Members EJ and IJ of a steel truss are subjected to a temperature rise of 30 degrees centigrade. If alpha is equal to 12 into 10 to the power of minus 6 mm per degree centigrade, then displacement of E relative to H in the direction of EH is, that is the question. Now you see he is asking displacement of E relative to H. So the question is like this. This point, this is E, J, I, G, H. This length is say 3 meters. This is also 3 meters or 3000 mm. This is also 3000 mm. So many values they give you 0.568. So like this questions are given, let us say. First we will see the scope of the work. Relative displacement of E and H. Delta EH. Formula is same, I told you, PKL by AE. Now, PKL by AE, we can write summation of K into delta. That delta can be PKL by AE, or it can be alpha TL, or it can be lack of fit. That means improper cutting delta can be there. So now we will use that formula. In this case, EJ, IJ members are subjected to a temperature rise. That means they will expand. Only two members will expand, others will not expand. Okay. So delta values we can find, K values we can find, then multiply them. What is K here? Where K is equal to forces in all members due to unit loads. Due to unit loads applied at E and H, and those unit loads must be applied in the direction of EH only. Only then you will get the relative displacement. Otherwise, some displacements you will get, some displacements you have added, then you cannot call them as relative. Relative means they must be either towards or they must be opposite to each other. One of the member must, two bodies are there, you must be on one member and see other member velocity. So they must be in the same direction, means they must be parallel. So in the direction of EH. So delta values we have to find, where delta is equal to, in this case, alpha TL for each member. So your first step is delta, second step is K, third step is multiplication. Now let us see how we have to proceed. First step. delta values. Delta for EJ, alpha TL. Alpha is 12 into 10 to the power of minus 6. Temperature rise is 30 degrees centigrade. Length is 3000 mm. So 12 into 9, 1.08 mm. This is elongation. So delta Ij, again alpha TL, 12 into 10 to the power of minus 6, 30 degrees centigrade. Length is 3000 root 2. Why? In this case, if this is 3000, 3000, diagonal length is 3000 root 2 mm. Okay. So 3000 root 2. So you will get 1.528 mm. These are expansion, they are elongations, we can say. So for all other members, delta is equal to 0. Why? Because there is no change in temperature. Only two members are subjected to temperature rise, other members no temperature change, so no expansion, no contraction. Okay, so delta is 0. So first step is over. Then second step, K values. Now you see, this is the truss. E, J, I, G, H. Then 45 degrees angle also we know. Now, you should not apply only one unit load, you should apply two unit loads in the direction of E and H. Those two unit loads can be either towards each other or away from each other. So let us assume that both the joints are moving towards each other. 1 and 1. Okay, two unit loads we have applied. Now the angle of inclination also we know, 45 degrees, 45 degrees. In strength of materials you have studied one point. In any statically determinate structure, it can be a beam or truss or a frame, if it is subjected to a system of forces which are already in equilibrium, then reactions will not develop. Reactions are always 0. Why? You see, this is the problem in the simply supported beams you have studied. Assume that you have a simply supported beam subjected to a moment m. It is a statically determinate. Right? 1 m clockwise, 1 m anti-clockwise. So this beam is simply supported beam is subjected to a system of forces which are already in equilibrium, plus m minus m. Then supports will not react. And you have studied Va is equal to 0, Vb is equal to 0. This case not only in the beams valid for trusses, frames, anything. Coming to this one. This is a truss subjected to a system of forces, is a statically determinate, one end hinge, one end roller. Because it is a statically determinate structure subjected to a system of forces, two unit loads, that is system of forces means group of forces, two unit loads which are acting along same direction means they are in equilibrium. Sigma x 0, sigma y 0, no couple is also forming by these two loads. So, Vg is equal to 0, Hg is also 0, Vi is also 0. Just by inspection itself, you should be able to get it because you have already studied that. Determinate structure, system of forces which are already in equilibrium, reactions need not react, they simply keep quiet. Here also same thing, support reactions are 0. 5 seconds you should be able to keep that they are 0. Next, we have to see the member forces. This member forces calculation must be over in less than 1 minute time. Last class's method of joints and sections, finding one member force itself is a 2 marks question. Now finding forces in all members itself is also a small part of a problem. Questions will be such that by inspection itself we will be able to keep all the forces. How you have to analyze? Joint I, reaction is 0. At this joint, two members are meeting which are non-collinear, means not in the same line. Two non-collinear members with no external load at that joint, if such situation is there, forces in both members are 0. Force in both members are 0. Next, come to this one. 1. One sine 45 is acting upward. See, arrow mark is going like this. It's going up to the left like this, but it's going up. So, 1 sine 45 is upward. To balance that, it should be downward force. Put downward force. 1 sine 45 how much? Immediately should not take calculator, where is 1, then 1 into sine 45, then 0.707. That much headache should not be there. 1 sine 45 means 0.707. Should be able to write. So you fixed arrow mark here. You fixed arrow mark here. Now, because upward I have kept downward. Because arrow is towards the joint, here it should be towards the joint. Okay, next. Now, 1 cos 45 is going left side. To balance it, here force must be right side. How much? 1 cos 45 means 0.707. If it is towards the joint, here also it should be towards the joint. Issue closed. Then come here. 1 cos 45 is going like this, right side. To balance that, it should be left side. 0.707. Now, arrow is towards the joint. You fix this arrow now. Next. 1 cos 45 or 1 sin 45, both values are same. So, 1 sin 45 is going down, here 1. So, to balance it, it should be up. How much? 0.707. Towards the joint? Towards the joint. Next, come to find this much force, again don't have to think too much. See, H and G are same. These two arrows towards, away. Towards, away. That's all. Should be away. How much? Towards, 0.7. Away is 1. Towards, 0.7. Away must be 1. So, this is away, this is away. 1. That's all. Here also 1 means here also you can put it as 1. But doesn't matter. Like that, see, to explain it, it has taken so much time, but otherwise when you are solving 1 cos 45 up, so put downward arrow mark. This is left, then put right side arrow mark. Issue close. Then repeat everywhere. 15 seconds or 20 seconds you can close the problem. But such fundamentals you must have the familiarity. Again, finding that sigma x 0, sigma y 0, sigma m 0, if you write and tell that they are 0, your 2 minutes will go only in finding the reactions itself. Okay. So, after finding the k values, now third step is k into delta. This I think I will remove. Now, third step. Relative displacement of E and H. Nothing but summation of k into delta. We will first tabulate it. Member K. First K values we have already written. Delta values are 0. So delta, we can write delta here, K here. Then relative displacement of E and H, summation of K into delta. Okay. Now this is the sign convention. Tension corresponding deformation, elongation, take it as positive. Then compression corresponding deformation, contraction, take it as negative. This is the sign convention. Okay. How many members we have to list? See here, delta Ej, delta Ij. Only two are there. For all members, delta is 0. So we don't have to write that and we make it as 0 and waste our time. So in the table, only two lines must be there. If you are writing third line also, then immediately stop. Must be some way of getting out because it's only a 2 marks question. So first we'll write member Ej. Delta. See elongation. So plus 1.08 mm. Next K. K for Ej is arrow mark is towards the joint. So minus 0.707. Multiply them 0.764 mm you will get. Next Ij. Delta you see plus 1.528 mm. K value. Ij K value is 0. That means this value is also 0. Then here first problem, so I am writing all, but in the exam you skip these lines. For all other members delta is 0. So whatever may be the K values, it is 0. So these things, these three you don't have to write. Having found that Ij value K is 0, you should not waste time writing this also. Only one line. Questions will be set such that you will not be asked to calculate too much or think too much. It will be finished in maximum of 2 minutes time or 1.5 minute time itself. So delta EH you will get minus 0.764 mm. Here simply minus indicates that the relative displacement is opposite to the direction of unit loads. You thought in the beginning that E and H they move towards each other. Negative sign means they don't move towards each other, they move away from each other. Only that's all. That is the implied meaning of minus. So negative sign implies that the joints E and H will not move towards each other. They move away from each other. That is opposite to direction of unit loads. Direction of unit loads, so you have shown like this, but they will go this way. That means they move away from each other. Okay. So 0.764. They didn't give you here whether it is plus or minus. So simply 0.764. So put it as 0.764 like that. Okay. This is about the relative displacement of any two joints. It is now we have given temperature changes. It can be due to loads also. Due to loads, two forces, two deformations they will give you. Only two PL by AE values for two members only. All other members you will get PL by AE value is 0. Then fill the same table in the same manner. Okay. Then due to lack of it, again we'll see later those problems. Okay. This is about relative displacement. Now we'll see the third example of Castigliano's theorem 2. Third application, rotation of a member. Okay. Now, as whatever the things that we have observed, we will write them as points. See here, first observation is this one. How we could keep them as 0 directly? We'll write that as a point. So now first observation is this one. If any statically determinate structure is subjected to a system of forces which are already in equilibrium, then support reactions are always 0. But this is valid only if it is a statically determinate structure. For indeterminate structures, again, even if you apply a system of forces which are already in equilibrium, reactions may develop. That we will see in the fixed beams how they will change. What forces them to develop the reactions. Here, no reactions will develop. Then, second point is this one. You have heated two members, EJ and IJ. When you heat two members, they will expand. If they expand, what type of stresses will develop? When EJ, IJ are expanding, what stresses will develop in all other members? You will find that not only here, in any statically determinate structure, due to temperature changes or due to sinking of support vertically or yielding of support horizontally or due to lack of fit, whatever may be the reason, no forces, no stresses will develop in any part of the structure. Okay. So, you see here, this is what you have studied in the strength of materials. See here, if you take a cantilever beam, this point let us say A, B, length of the member is say L. Now you go and hit this one, what will happen? It will expand. B will go to B dash, this is alpha TL. Now this length is L, change in length is alpha TL. What stress will develop? There is a strain here. What is strain in this member? Alpha T. Just because strain is there, stress need not develop. That's what you have learned. They are called free strains. Without any stress also, strains can develop. Strains means change in length by original length, but that change in length can be due to anything. If that change in length is due to loads, then the stress will develop. Strain or stress will be there, strain will be there. Natural thing, the temperature changes, no stresses, but still strains can exist. Okay. Now, strain is alpha into T, but no forces will develop in any part of the structure. You heat it, it will expand because of the intermolecular activity, it will expand. For that expansion, this support will not react. That means there is vertical reaction is 0, horizontal reaction is also 0, moment at A is also 0. This will happen only for statically determinate structure. For statically determinate structure, no stresses due to temperature changes. Right? This is what you have learned in strength of materials. Same thing is applicable to trusses, also frames. If it is determinate, no forces will develop. Why it will not develop? If you heat it as a rigid body, it will translate. Rigid body translation means without developing any stresses, if they move, we call it as rigid body translation. Now, as a rigid body, it will translate. That means no stress developed, but it is moving. So, we can idealize that as a rigid body translation. So, similar to the rigid body translation, we can take it. So, no stresses will develop. Now, second example is this one. Assume that you have a simply supported beam A, B. If one of the supports sink down, why it sinks down? Due to external reasons not related to the loads on the structure. No load is there, but still support can sink. Support means there is a column here, say. This column is resting on a footing. That footing is resting on a soil. If soil goes down, why soil will go down? Maybe liquefaction of soil or water level rises, so strength of the soil reduced. So this footing associated with that column both are sinking down. See, that is sinking down not because of load on this one, because of some other problem, not in the control of the beam. If it is going down, this roller simply goes down with that and it will rotate here, theta. In this rotation, no stresses will develop. It is like this. One simply pin connection, roller support. If this column is going down like this simply rotates without developing any stress. Such rotations we call them as rigid body rotation. Okay. So this is again determinate structure, no reaction here. For this also, now for this also no reaction here. VA is 0, HA is 0, VB is also 0. Now VB is the reaction exerted by the column on the roller. It will not exert any reaction, it simply will go down, and when it is going down, it will facilitate, it will simply go down, that's all. Column will not exert any reaction on the beam. Now, why column going down? It doesn't know. Because it's going down, this fellow will follow. That's all. Okay. So this is rigid body rotation. This is a determinate structure. No stresses due to sinking of supports. Next, sinking of support. Generally, sinking means vertically down. Yielding, we take it as horizontal. But you can take it support yielded and moved vertically down. Support yielded and moved horizontally. Their yielding means resigned. It resigned and went down. It resigned, moved horizontally. Like that. Third example we'll see here. You have studied about the arches, arch construction. Again, we'll discuss separate chapter on this one. Now, this is a statically determinate structure, A, B. Due to some reason, assume that the support has yielded and translated horizontally. Then, this one will take this position. B will go to B dash. This value say delta. We call it as yielding of supports. Why supports yield? This again is resting in the on the banks of a river, say. These two are piers on the banks of the river. Then what happens? One side soil is there, this side water is there. Let us assume one side water, one side soil. Then water pushes the pier, on the other side soil will stop it. Let us say it's like a small culvert type thing, let us say. So what happens? Water pushes it outside, soil keeps him in position. If at all water pressure is more, the support will move out slightly. Soil is exerting pressure, but still that was not sufficient, so it can push it further. So then you have studied in soil mechanics that the pressure exerted by the soil on the pier is called passive earth pressure. If at all the that is this goes inside, suppose, then inside means towards water side. Then the pressure exerted by the soil on the pier we call it as active earth pressure. So those things that soil structure interactions, the your soil mechanics sir will deal. So this arch is resting on the two pairs water, soil. They are fighting with each other on the column. This fellow, top fellow, simply observes from top what is happening between them. That's all. So no reactions will develop. In this case also, this is freely this offers no resistance to this horizontal displacement. This horizontal displacement because of the yielding of support. So VA is 0, HA 0, VB 0, HB 0. But still everything is 0, but still it moved not because of loads on the structure, but because of soil and water problem below the structure level. This is also a statically determinate structure. Three hinged arches are statically determinate, you have studied. Again, later on, we will see how to find static indeterminacy for beams, trusses, frames, etc. All we will discuss. But I am now taking for granted that a three hinged arch is a determinate structure because there are four reactions, three equations of equilibrium, three external equations of equilibrium, sigma x 0, sigma y 0, sigma m 0. Internal equilibrium equation is bending moment at c is equal to 0. So, four equations, four unknowns. You can find them statically determinate. So, no reactions due to yielding of supports. Next, last example, lack of fit, let us see. Assume that we have a statically determinate truss you are building. This point A, B, this point let us say C. This is say 1 meter, 1 meter, and naturally BC length is 1414 mm. Root 2 means 1.414 meters. 1.414 meters means 1414 mm. You ask the welder to cut 1414 mm. What he will do in the process of cutting, he may skip off that 14 mm, 1.4 meters only he cuts it say. Then 14 mm lack of it. That means if he cuts it such that there is a short, after cutting it you find that it comes only up to here. C comes to say C dash. This much he missed it. Instead of cutting 1414 mm, he cuts only 1400 mm. 14 mm he forgot. That means he didn't measure it, or in the process of cutting he slipped it. This much error is there. This is called lack of fit. What is the meaning of lack of fit? Fitness is lacking. Fitness is lacking means exact fitting is not there, it is missing by 14 mm. Such cases, now what we have, everybody will do, then just pull it and bolt it. When I am pulling and bolting it, will forces develop. We see this joint is now in air. Triangulation didn't form. So as it is in this case, it is a mechanism. Simply whatever you want. Why this much? If you tap like this, it will fall, rotate 180 degrees also. So here we are to build. Triangle also didn't form. So it is a mechanism. So easily you can, without developing any stress, I can pull and bolt it. Only thing that happens is the straightness will be lost. It won't be vertical, it will be inclined. Slightly it will be inclined like this. It comes like this, say. Now it will fit into this one like this. B will go to B dash, C dash will go to C. So this much loss will be there. Instead of straight 90 degrees, you may get 89 degrees or 88 degrees. That much error will be there. But no forces will develop here. VA is 0, HA is 0, VC is equal to 0. Again, this is statically determinate structure. No stresses or no reactions. Or we can say no stresses also. No stresses due to lack of fit. That means there are four reasons we have seen: due to temperature change, due to sinking of support, due to yielding of support, or due to lack of fit. No stresses or no forces will develop in any part of the structure. Why? Because either rigid body translation or rigid body rotation will take place. It's like a translation, it's like a rotation. As a rigid body, they will rotate without developing any stress. Why it rotates as a rigid body? Just a sufficient number of reactions only are there. So it will not undergo a deformed deformation. Rigid body, it will translate. Either it will translate or rotate in a statically determinate structure due to these external actions. So we can write a conclusion like this. This I remove. After seeing these observations, we can write a conclusion. It is applicable to everywhere. It is for beams, trusses, frames, same. So you can write a conclusion like this. In any statically determinate structure, due to temperature change or sinking of supports or due to yielding of supports or due to lack of fit, no stresses are developed in any part of the structure. No stresses statically determinate. This is like assertion. What is the reason? Because rigid body translation or rigid body rotation or rigid body rotation takes place due to these four actions. That is the reason. Now, this is about the second example numerical. Next, third point is rigid body rotation. Using Castigliano's theorem 2, we can find the rotation of a member in a truss. How to calculate in our stipulated 2 minutes time? Now let us see a third numerical. Rotation of member AB is. This point, let us say A, B, C, D. Okay. This contracted say minus 2 mm. This is plus 4 mm, minus 2 mm, plus 5 mm. This is 0. Assume that you don't worry that how this 5 mm or 2 mm, 2 mm came. Arbitrarily, I have given. Maybe they are due to temperature change, or due to lack of it, or due to applied loads. Whatever may be the reason, they have given us the deformation of each member. Okay, so we know the deformations of each members, and to save our time, that PL by AE or alpha TL values directly they have given us. Okay, now you want to find, because of these deformations, how much this member AB rotated. Okay, that is our point. First, we'll see what is the scope of the work. Rotation of member AB, theta AB is equal to summation of PKL by AE. Formula is same, I told you. I can write summation of K into delta, where K is equal to what? Forces in all members due to unit couple. Unit couple applied at A and B. Then delta, displacements already they have given. Delta is equal to PL by AE or alpha TL for each member. These are already given. That means delta values are not required, already given. So in the first step, you have to find K values. Second step, K into delta. Okay. So let us see how to find that. Here itself we'll write otherwise. First step, K values. This is a roller support. This is a hinge support. This point A, B, C and D. These lengths are also given. In this problem, from here to here, this length is 3000 mm. This horizontal distance, this is also 3000 mm. Okay. Now 3000 means this length is now here 3000 here. This is also 3000. That means 3 meters length. Now we have to apply unit couple. That unit couple at A and B, you can apply clockwise or anti-clockwise, our choice. If the result works out to be negative, then our assumed direction is wrong. Opposite to the direction of unit couple, displacement will happen. So two forces we have to show. This is 1 by A, the fundamentals have given. So 1 by A here means this length of the member. So 1 by 3000. Unit couple means 1 by 3000 into 1 by A into A is equal to 1. That 1 has no units. But 1 by A has units of mm power minus 1. See, this is 1000, 1 by 3000 mm. So 1 by 3000 mm power minus 1. Here also it is 1 by 3000 mm power minus 1. So this is the couple we have applied. Unit couple. And to find the K values, forces in all members due to this unit couple should not take more than 15 to 20 seconds time. Let us see how we have to finish. 1, 2, 3. 2 are in line, so third must be 0. This arrow right side, to balance it, it should be left side. How much? Same, 1 by 3000. Now you see how arrow mark is. Away from the joint, away from the joint. Leave it off. Come here. Already it is 0. Now at B, how many are there? 1, 2, 3. 2 are in line. So third must be 0 now. This arrow is acting left side. To balance it, this arrow must be right side. 1 by 3000. Okay. If since arrow is towards the joint, here also it should be towards the joint. Over. Next, roller support, we know that it will give only one reaction, HC. So now 1, 2, 3. 2 are in line. Third must be 0. HC, arrow is left side, 1 by 3000, it should be right side. 1 by 3000. Now see here right side, so it has to be left side. 1 by 3000. Now you may get a doubt that this truss is subjected to a system of forces which are already in equilibrium. If you write sigma x 0, right side force, left side force balanced. Sigma y already 0, but sigma m is not 0. So this is not a system of forces which are already in equilibrium. Those two forces put together will form a couple. To balance that clockwise couple, anti-clockwise couple should develop by the reaction. Then it will be in equilibrium. If at all these two forces are in the same line, then reactions is there, simply keep quiet. Like that. So support reactions are over and member forces are over. Then second step, theta AB is equal to summation of K delta. So you will write member, see K values, delta, then theta AB is nothing but summation of K delta. Sign convention again, tension corresponding elongation or positive. Compression corresponding contraction or negative. Okay, how many members we have to list? You see, these three are 0, only 2 you have to take it. So, member AD, K value, see arrow mark is away from the joint. So, plus 1 by 3000. Delta you see minus 2 mm, that means contraction. So, you will get K into delta means minus 2 by 3000. Don't simplify now itself. Next BC. BC K value arrow is towards the joint. So, that means compression minus 1 by 3000. Elongation plus 4 mm. So, you will get again minus 4 by 3000. So, for all other members, K value 0, then whatever delta it doesn't matter, theta AB 0. What does that mean is theta AB 0 for all other members. The other members, the vertical member, diagonal member, vertical member, they will not influence the rotation of the vertical member AB. That means what, whether it is, I have written 5 mm, 0, 2 mm, whether it is minus 2 mm or plus 4 mm, plus 5 mm or plus 10 mm or minus 10 mm, they have no influence on the vertical member rotation. The contribution of those three members in the vertical rotation of the member is nil. Okay. So now theta AB, that's why I have given you some arbitrary values there. So theta AB you will get minus 6 by 3000. This you can write it as minus 2 into 10 to the power of minus 3 radian. So one of the options will be 2 into 10 to the power of minus 3. Now you got minus. The implied meaning of minus is you didn't know in the beforehand whether the member AB rotates clockwise or anti-clockwise. You assumed clockwise rotation, you solved it. Negative you got. That means that the AB member will not rotate clockwise, but it rotates opposite to the couple. Anti-clockwise it will rotate. So that is the implied meaning here. Negative sign implies that the theta AB is opposite to unit couple. That is theta AB is anti-clockwise. Like that. Supposing that for this problem, you have taken say 1.5 minute time. Let us say 2 minutes time it has taken. Assume that in the examination you have only 10 seconds time and invigilators are pulling the paper, you want to tick it and get out. Such cases you have a second method available where you can complete in 10 seconds time. That method you can apply only if you know the displacements of the member in the perpendicular direction. Then rotation you can find it. Then I have given you for this fundamentals for this example. Those fundamentals will take it and complete the problem fast. So that second method we'll see now. This I remove it. When displacements perpendicular to the member are known at the ends, Then only you can simplify this one. AB member vertical, but how much A goes inside or outside if I know, or B goes inside or outside if I know, then I can manage. Come to this problem. DA member is shortened by amount of 2 mm. Minus 2 mm means it got contracted. If you stand at D, look at A, this A member will go left side or outside. Minus 2 mm is contraction. That means A will go in by 2 mm. So that means AB member to the AB member perpendicular direction, how much A moves we know. Come to CB member. It is this CB member is elongating by a distance of 4 mm. Now stand at C, look at B. B will go in or out. It will go out by 4 mm because it is elongating. So perpendicular direction displacement is known. So this is A, this is a B. This length is now 3000 mm. Now point A has moved to left side to A dash, let us say. This is 3 mm, 2 mm. Next B has moved out by 4 mm. This is what we have given in the fundamentals, member GF. So G went up, F went down, then I have drawn a dotted line and rotation I found. So that process we are taking. Now after this displacement, the final displaced structure is like this. In the process, it also contracted 2 mm. Out of 3000 mm, 2 mm, whether that contracted or elongated, it has no influence on the rotation. Because that 2 mm means it is a second order displacement you will get. So that rotation we will neglect. So how much it moved completely? 2 mm here, 4 mm. That is delta Fg when you have Gf when you have written. Delta G by A plus delta F by A we have written. So that process, this total displacement is 6 mm. Now you see, the rotation of the member AB means this one. This is the rotation of the member, theta AB. Why we have to write here? Black color line is the initial position, blue color line is the final position. To get that final position, what we have to do? From the blue color line, first I have to translate up to here. Stop there. Now to get blue color dotted line, I must rotate anti-clockwise. How much is that tan theta AB? Is approximately equal to theta AB. Opposite side is 6 by length is 3000. So this you will get 2 into 10 to the power of minus 3 radian anti-clockwise. Like that. Supposing that this you don't get, here you want to find say, then also no issue. Anywhere, this is the initial position, final position. First you try any rotation if you want, that's how you have to take it. This is the rotation say, how it rotated you want to find say. Where is the initial, where is the final, how to get that? From the initial position, first you translate up to here. Now to get the blue color dotted line, I must rotate like this, anti-clockwise. So whether you see here or here, it is anti-clockwise only. See here, this will hardly take say 20 seconds time. Even the 20-second time also is not there, only 5 seconds time is there. Now that you have understood this one, you see here without the diagram also you can manage. Minus 2 mm, A went in by 2 mm, B went out 4 mm. So 4 plus 2, 6 mm. 6 mm is the total horizontal displacement. 6 by 3000, 2 into 10 to the power of minus 3 radian. Even this diagram also not required if you have only 5 seconds time. Then 20 seconds time is there, you can do like this. 2 minutes time is there, you can do that way. But this experiment, you do it beforehand, then in the exam you will have confidence that okay, this is how it's given, I can manage. But that's why in one of the GATE papers they asked this question. Now that you have understood how to complete them, complete it in 5 seconds time, next time what they gave was another GATE paper, they asked the rotation of the member BD. So BD member in the perpendicular direction, you don't know the displacements. So this type of graphical way of finding the displacement is not possible. You have to do it completely. So that problem we'll see now. Now you want to find rotation of the member BD. So theta BD is summation of K into delta. K stands for now forces in all members due to unit couple. Due to unit couple applied at B and D. Delta already given. So the first step is K values. So this is our truss. This point, let us say A, B, C, D. This length is now 3000 root 2 because diagonal length is so much. Now unit couple you have to apply here. This value here and here. This is a unit couple. 1 by A now means 3000 root 2. 1 by 3000 root 2 mm power minus 1. This is also 1 by 3000 root 2 mm power minus 1. Okay. Now find the forces again. Within this should not take much time to find the forces in the members. Okay. At A, two non-collinear members, no external load. That means forces in both members are 0. Next, this is 45 degrees. This is also 45 degrees. At the joint B now, if you apply sigma y0, 1 by 3000 root 2 cos 45 down, then to balance that, this will not contribute in the vertical direction. So this is useless. Since angles are same, forces must be same in these two. This is going down, it should go up. How much? 1 by 3000 root 2. Now see, 1 by 3000 root 2 this way, 1 by 3000 root 2 up. Its vertical component going down, this vertical component going up. So they balance each other. That means at a joint, if two members are there, if slopes are same, forces must be same. Otherwise, sigma y0 will not happen. This going down, this going up. For sigma y0 to happen, these two forces must be equal. Okay, arrow mark away from the joint, away from the joint. Next, sigma x0, if I take it, 1 by 3000 root 2 cos 45 is going left side. This is also going left side only. Let it go, both of them, let them go left side, but third one can go act right side. So this will go right side, towards the joint, towards the joint. How much it is? 1 by 3000 root 2 cos 45 means 1 by root 2 again. So here 1 2 will come, 1 by 3000 into 2. This also same, 1 by 3000 into 2. So 2 times when you add it, you will get 1 by 3000. So towards the joint, towards the joint. Now this acting left side, reaction only 1. So 1, 2, 3, this is 0, this is 1 by 3000. Now you see both of them are acting right side, so left side 1 by 3000. Assume that you didn't understand how I got 1 by 3000. Such cases, if you think you don't understand, first you calculate. Then observe how the each expressions are getting added, how they are behaving. So second time when you are doing it, that much trouble will not be there. Such cases you have to do like this. This is what I told you. At joint B, you write sigma x is equal to 0. Any force that acts right side positive, left side negative. See this one, 1 by 3000 root 2, acting left side, going downwards means down to the left. So 1 by 3000 root 2. Now we see 1 by 3000 root 2 cos 45. You will get this angle is also now 45 degrees. So whether you write cos or sin doesn't matter. 3000 root 2 cos 45. And the other force also same, minus 1 by 3000 root 2 cos 45. Now it has to be right side, FBC plus FBC is equal to 0. Now this what I told, cos 45 means 1 by root 2 into root 2 minus 1 by 2 into 3000 minus 1 by 2 into 3000 plus FBC is equal to 0. 2 times they are there, so 2 we can cancel. So FBC is equal to 1 by 3000. Arrow mark towards the joint, compression. Such cases, this much we should not do and tell that 1 by 3000. We should be able to read it. Now I read it, you understand. 1 by 3000 root 2 cos 45, 1 by 2 into 3000. This is 1 by root 2, that is 1 by 3000 root 2 into cos 45. That means 1 by 3000 root 2 into root 2. So 1 by 2 into 3000, 1 by 2 into 3000, 1 by 2 into 3000. That means sum them 1 by 3000. So 1 by 3000 left side, right side 1 by 3000. That's what is called reading of the forces. Supposing that if it is in the exam, if you are under tension, then you have to spend 10-15 seconds extra time and do that only. That's why on the exam day, you must not eat too much and go to the exam. If you eat too much and go to that, entire blood goes only in digesting the food only. Less blood goes to the brain and it will not think too much. It will sleep. Okay. Now, having now understood how it comes 1 by 3000. Now you see, you go to the second step. Theta BD is equal to summation of K delta member K delta and theta BD. So members, only two members you have to write. Member BD, K value is 1 by 3000 root 2, tension away from the joint. So plus 1 by 3000 root 2, delta plus 5. So you will get 5 by 3000 root 2. Next, BC member, K value towards the joint, so minus 1 by 3000. This is plus 4. So finally you will get minus 4 by 3000. For all other members, delta 0. That K value 0, so we don't have to write. So you will get theta BD. So a simple calculation. You will get minus 1.54 into 10 to the power of minus 4. Now you have assumed clockwise. Here also So negative implies that theta BD is opposite to unit couple. So theta BD is anti-clockwise, like that. Now we'll see one or two examples on the lack of fit. We have seen the questions on the deflections when loads are applied. Deflections are relative displacement when there is a temperature change or when there is a rotation. If at all one member we could not cut properly, let us say there is some lack of fit. Because of that error in the length, how much displacement a joint will undergo? Such problems we will see now. Okay, for the like these questions will come. For the truss shown in figure, member PQ is short by 3 mm. PQ is short by 3 mm means we could not cut it properly, 3 mm less we cut it. It is short by 3 mm. The magnitude of vertical displacement. The magnitude of vertical displacement of joint R is. Now this is the question. P Q, this is R. This distance is 4 meters. This distance is also 4 meters. And this is 3 meters. Let us say member PQ is short by 3 mm. Why it is short? Because of maybe they could not cut it properly. Okay, some reason. That means by that statement, PQ is short by 3 mm means other members are not short, not long, exact sizes they are. The implied meaning is that only. So PQ is short by 3 mm means minus 3 mm. If they say PQ is long by 3 mm, that means it is like extension. So plus 3 mm we could have written. By seeing that on the truss, you have to write this one. That means the deformations of all the members are given with that statement. Now the scope of the work is this one. Note. Delta vertical displacement of R, summation of PKL by AE, summation of K into delta. That PL by AE, I told you in the beginning, delta is maybe PL by AE because of PL by AE or because of alpha TL or because of this type of fabrication error. Okay, K delta. Delta values are already given where K is equal to forces in all members due to unit vertical load. Unit vertical load applied at R. Okay, so delta values are so in 2 minutes time. Now in this case, now we try to save some more time. This delta values are 0. If delta values are 0 for 2 members, in the table how many members we have to list? Only one member, PQ. because other members are 0. So instead of writing table and wasting the time, you can simply write like this: K of PQ, delta of PQ. That's all. So in 2 minutes time, our task is to find KPQ, multiply them, only one member. Okay, to find, this is how your solution goes. To find KPQ. P, Q, R. Now we don't know whether assume that we don't know whether it goes down or up. It goes downward. 1. This 1 has no units. Because of 1 here it is 0.5, 0.5. The reactions are like that. Now this height is 3. This is 3, this is 4, so theta. So tan theta is equal to 3 by 4. You'll get around 36.87. So if this is upward, it has to be downward. Because of symmetry, it should be same, downward. If this goes right side, this arrow must be right side. So this is KPQ. This is KPR. If you write sigma y0 at P, if you write sigma y0, what happens? Plus 0.5 minus KPR sine 36.87 must be 0. So KPR, you will get around 0.83 compression. Then if you write sigma x0, this going left side, so minus 0.83 cos 36.87 plus KPQ must be 0. So KPQ you will get 0.67 plus you are getting, that means it is tension only as it is. So KPQ value will get 0.67. Now once KPQ is known, we can calculate delta vertical displacement of R. KPQ delta PQ. This is plus 0.67 into minus 3. So you will get minus 2 mm. Now negative sign indicates that the vertical displacement is not downward, it is opposite to vertical load. That means upward. Negative sign indicates that delta VR acts opposite to unit load. That is delta VR is upwards. Okay, 2 minutes time. Now come to this problem. Delta VR upwards, why it is like that? Suppose PQ member is supposed to be 8 meters. So he has cut 7.997 meters. 3 mm error came. So it goes in. When Q goes in, this will go up. Assume that in the beginning we could not understand that point. So we assume that it is acting or the displacement is downward. Finally, you will get negative result, then it means that you should go up. Then if you see it is correct only. When we are pushing it inside, it will go up only to accommodate that inward displacement. Okay. So this is one thing. Another thing is, another problem, you see it goes like this. Next question. For the truss shown in figure, member ij is fabricated 10 mm too long, 10 mm too long, then vertical displacement of joint E. What is the vertical displacement of joint E? This is the truss. One, two. Here both ends are like this. Pin here, here. This is a bolted connection. A, B, C, D, E, F, G, H, I, J. Lengths are also given. A, like this are given, say. This is also A. So member IJ is fabricated 10 mm too long. That means it is 10 mm too long means plus 10 mm, which implies that all members are not fabricated either long or short. They are correct only. If this is IJ member, instead of A plus 10 is there, say 10 mm extra, joint will go down or up? Now it will go down. How much it goes down is the question. Now you can apply one unit load here. 1. It has no units. Now you see delta vertical displacement of E. Then summation of standard formula is PKL by AE. No forces are there, K delta. Now delta is due to fabrication error. PL by AE can be there, alpha TL or fabrication error. K delta. Delta is known to us. Only one member delta is there, all other members delta is 0. So Kij into delta Ij. In 2 minutes time your task is, say 1 minute time your task is to find Kij. Due to unit load, what is Kij here? Now we are not interested in K values of all other members and we don't want to waste the time. So for that what we do is, it's like this. If you use method of sections to find Kij, because intermediate member if you want method of section only better. So cut it by 1 1. Look at RHS of 1 1. This is clockwise. To balance it, it should be anti-clockwise. So this is Kij. Why it is anti-clockwise you are taking? When you cut it and take right side of equilibrium of 1 1, these two unwanted members are meeting at B. It's like this. Kij. Cut it by 1 1. RHS of 1 1. Take moments of all forces about B, equate it to 0. Clockwise positive, anti-clockwise negative. So plus 1 into 3A minus Kij into A. So Kij you will get plus 3. That means tension. Now delta vertical displacement of E. Kij into delta Ij. Delta Ij we know. It is delta Ij is plus 10 mm. Then for all other members, delta is 0. As per his statement, it's given. So Kij you get plus 3, delta Ij is plus 10. So you will get 30 mm. In 2 minutes time, your task is only this much. Okay. So first we should have very clear picture on the topic displacements. Castigliano's theorem 2 is used for the truss displacements. In the exam, if they give you any truss displacement, means it must be the Castigliano's theorem 2 only we have to use. Either displacement or relative displacement or rotation of any member. Could be due to applied loads or temperature change or due to lack of fit. Okay, these are the possible examples which will be over in 2 minutes time. Okay, if you have say indeterminate structures, find forces say, then we don't use the strain energy method, we go for the stiffness matrix method of analysis where we can complete in within 1 minute time. We'll see what type of questions they can ask in those topics. So this is about the second topic, the deflections in statically determinate trusses only. That displacements actually, it can be linear displacement or angular displacement. Okay. So all questions, any question given now, you will be able to answer. Now we'll see the third topic. We'll discuss the third topic. Analysis of statically indeterminate trusses. How the questions are likely to come. In this indeterminate truss analysis, they will only ask you to observe the overall behavior of the structure. Numericals not possible because of the time it takes. Okay. Likelihood questions are like this. Force in the member AB. Assume that we have this member, let us say A, B, C, and this load, let us say W. This angle, let us say 60 degrees, 60 degrees. Okay. This we want to find force in the member AB. To find force in member AB, we must know the structural behavior of the hinge supports, how the hinges offer resistance to the applied loads. Okay. Though you have learned in strength of materials about the behavior of hinge support, roller support, fixed support, I'll briefly review what you have studied. Note 1. Types of supports. This is like a hinge support. It looks something like this. Just schematic diagram I have drawn. There is a bolt here. There is also a bolt here. This point let us say A. This point let us say B. Some load we have applied, say W. This type of support we call it as hinge support. Hinge supports, actually you have two plates. This one, when we show a triangle like this, actually there are two triangles. Front one triangular plate, back side also one triangular plate must be there. Then between them triangular plates, this member will run. So it looks something like this. You see here, this the beam, you take it. This my finger, you take it as a triangular plate. Not one finger. Here also one triangular plate should be there. Otherwise, with single means connection will be eccentric. So two will be there, let us say. You take a drill bit, make a hole into the finger, into the duster, into the finger. Insert one nut, bolt, keep tighten the nut. That connection we call it as a hinge connection. Now you see there is only one bolt here. If I try to pull it out, it will not come because there is a bolt here that will stop this outward movement. That means this bolt is subjected to double shear. Supposing that pin, if it breaks here and here, then it will come out. That means the bolt is subjected to double shear and offers resistance to the rigid body translation of this member. So that will offer one horizontal reaction. It can offer one horizontal reaction. If I push it, reaction will develop like this. And that reaction is exerted by the pin on the beam. Then pin to the pin, who will give the force, who will stop the pin? Triangular plates. So first triangular plates will exert force on the pin. Pin in turn will exert force on the beam. Finally it will stop. Otherwise simply it will move either right side or left side. Now if you try to lift it up, it will not go up. Again there also it is subjected to double shear. So it can offer, pin can offer horizontal reaction, vertical reaction. Now however hard you tighten the nut, single force only, two forces are there like this. If I try to rotate like this, those two forces, resultant force will form only a single line. Here and here double shear, then you can replace it by a single force. Resultant reaction we can say. And that single force cannot offer a moment reaction. To have a moment reaction, there must be a couple. A force here, another force somewhere here must be there, then it can prevent the rotation. Since the second force, which is not in line with the first force, is absent, it is free to rotate. However hard you tighten the nut, still you see you can rotate like this. So rotation is possible. This pin cannot offer any resistance to the moment. So it will simply rotate. Then that means here whatever bolt is there, this bolt is subjected to double shear. Then why triangular plates, triangular shape we provide? That is because of the load dispersion. We have learnt, I think soil mechanics sir might have told you, that plate load testing when you are doing, when a plate on the plate, when you load it, if the plate is resting on the soil, the pressure variation is like a pressure bulb. That is interparticulate system. Soil is interparticulate system. It neither behaves like a solid or liquid or the gas. So interparticulate system. So such cases what happens? It varies like a pressure bulb. If you the same plate you put it on a concrete wall, then the effect of the load will be felt in the 45 degrees line. That means that is called load dispersion line. The load will be dispersed in this way. Beyond that zone, the effect of that load will not be there. If you take brick masonry or something like that, sirs might have told you, with respect to vertical, it is a 30-degree line. So in that way, it will spread. The dispersion line is like that. In steel structures, you have studied when you are taking web crippling, when you want to test it with horizontal, it will make 30 degrees, load dispersion line. Bricks, with respect to vertical, it makes 30 degrees line. So effect is relatively steep in that case. So 30 degrees with respect to vertical, or 30 degrees with respect to horizontal, or 45 degrees, or pressure bulb. Depends on what it is resting. Okay. Now similarly here, pin, when it is there, pin exerts like a point load. Effect of that point load on the steel, it is like a load dispersion line is 45 degrees line. So that's why you get a triangular shape. Okay. So this, if you put a rectangular plate here, say, then the that much of plate is simply plate metal is simply wasted, because the effect is not there at all. So that's why if you put a triangular one, you are effectively utilizing the triangular plate front side, triangular plate back side. Triangular plate, because of 45 degrees load dispersion line. Okay. Now this pin will exert one horizontal reaction HA, vertical reaction VA. So HA and VA are the forces exerted by the pin on the beam. And on the pin, for it, you have to first stop the pin. So pin is held by the two triangular plates, front side one plate, back side plate. So this is the pin, let us say. This one plate will hold like this. You have a beam like this. Beam, assume that a slotted one is there. Then beam pushes the pin first. Then pin will not go back because it is stopped by the two triangular plates. They stop it. So finally pin will be in equilibrium. And also member will be in equilibrium because of the all force system. So like that, triangular plate will exert force on the pin. Pin will in return exert force on the beam. Finally, we can say that as far as this free body diagram of the beam is concerned, on the beam, who is offering resistance, who is acting on that only, it will know. As far as beam is concerned, pin will exert HA, VA on the beam. To the pin who gave that VA and HA, beam cannot know, because beam is not in contact with the triangular plate. Okay. This is the behavior. Hinge support will exert two reactions. If at all here 3-4 members are there, say, then pins gap between the two triangular plates must be sufficiently long. That pin also will be too large. One member will go like this, side of that one more member, side of this another member, like that. All the members that long pin will accommodate, and that pin will rest on the triangular plates. That's how the arrangement is. So is the case here. Roller support. Roller support means you can have a, if at all the height between the beam and the column is sufficiently large, say, then you will put a triangular plate. You will bolt a triangular plate as in this case, and triangular plate will have a base plate. This is a base plate, steel base plate. Below the base plate, rollers will be there, and it will roll forward or backward. Okay. It cannot be lifted because you will have a mechanism, holding mechanism like this, so that it can slide forward and backward. You cannot lift it up. It cannot be lifted. Such type of things will be there. This type of roller support, what happens, how actually they look like. These rollers are like steel cylinders. Assume that this is a solid steel cylinder resting on the base like this, say. Then this is a beam. You keep it beam on the pen, in this case pen, but actually it is a steel cylinder. If I push it like this, the steel cylinder simply rolls forward, backward like this. This cylinder will not offer any resistance to horizontal reaction. If at all horizontal force is there, that roller simply rolls off. It says I cannot offer any reaction. Vertically, if you apply load like this, it reacts. Vertically upward, it will react, it will not go down. So vertical reaction is possible. Now try to rotate. This cylinder offers zero resistance to this rotation. It will permit the rotation. When the rotation is happening, this roller simply looks like that. It cannot stop the rotation. So that means this roller support will exert only one reaction. only one reaction perpendicular to plane of roller base. Okay, only one reaction here it is possible. VB. Okay, now another type of support is fixed support. Let us see how the fixed support looks like. This point A, B, C. When we say cantilever beam starts from A to B to C. BC is not cantilever. Some portion of BC must extend within the support, otherwise it will fall down. So cantilever beam beginning is A, this is B, this is C. The entire thing is one cantilever beam. Okay. Now, if you apply some loads, let us say on this one, you have applied some vertical load W, horizontal load some W1, some loads you have applied, let us assume. Then that support behavior is similar to like this. Supposing that my hand you take it as a fixed support, it holds like this. Fixed support means there may be a wall here, here also there is a wall construction, this is embedded into that, or it may be some concrete also can be there. Then whatever this beam inside, if you see the reinforcement, that reinforcement will go and be, it is bending upward or it will bend downward, so that if I pull it like this, it may not come, because bars are embedded from this to the wall, it is embedded. So horizontal pull it can offer, it will offer resistance to the horizontal pull. So horizontal reaction this can exert. Then vertical reaction, I apply vertically downward force, then this wall here will offer a vertical reaction. So two reactions. Now if you see the roller hinge support, it is freely rotating like this, movement is it's not offering. But if I hold it this way, apply load like this load, when you are trying to apply the load here, this load will try to rotate this member, that is called rotational effect of a force, which we want to call it as moment. That moment is not effect, the magnitude of that rotational effect is force into perpendicular distance. Now that moment will be resisted by this hand. In this case, you see, if I am pressing it down like this, say, what will happen? My hand here, this finger will exert a downward force. Then when I press it down here, you see this finger, conveniently I put one down here, one finger also was there. Like this I am not putting. So this wall will exert an upward force here. This downward force, this upward force. Between the two forces, there is a distance equal to my hand distance, maybe 5 centimeters like this. Okay. So one force here downward, one force upward. These two forces will form a couple, anti-clockwise couple. That anti-clockwise couple resists the clockwise rotation. So rotation of the member is prevented by a couple. That means at the fixed support, you have three reactions like this. One horizontal reaction, you can say HB, let it some value, whatever it is. Then you have vertical reaction VB, its value may be equal to W, and also a couple it will form. As I have explained to you, here there is a downward force F, here there is an upward force F. Perpendicular distance is D. This is complete free body diagram of a cantilever beam. Now, that's how it offers resistance. Now you will find that what's the total downward force on the cantilever beam? W plus F. Total upward force? W plus F. Now on this beam there is a clockwise couple. Blue color couple is W. This W will form a couple. Clockwise couple whose magnitude is W into L. This blue color couple is balanced by red color couple. F and F, perpendicular distance is D, F into D. So sigma m is also 0. So it will be in equilibrium. So this is like fixed support. This we idealize like this. This is equivalent to this way. There is a vertically downward force W. So now VB you called it as W, this force W1, then you have HB, some value, in this case W1 only you will get it. Then a couple. Instead of showing two forces, we do not know within the wall how the wall is exerting a pressure. Because displacement is more, it varies linearly. At the extremes, pressure intensity is more, somewhere here in between, pressure will be 0. Then the downward pressure, upward pressure, if I take it, the resultant forces I have shown here, but exact pressure distribution within the wall depends on the rigidity of the wall, how it will distribute. So somewhere it was acting here, and we have taken finally the resultant force down, resultant force up, perpendicular distance d you have taken. Okay, now this couple you replace it by an anti-clockwise movement like this. MB is nothing but actually F into D only, but F into D is also equal to W into L. Okay, so generally we will not know what's the perpendicular distance between the two forces F and F. So magnitude of F also we will be not knowing. So we replace that effect of the couple by a curved arrow mark. Now whether when you have studied in strength of materials or RCC or steel, wherever you study and you find that wherever there is a curved arrow mark, it means that there must exist a couple like this. Without such a couple, this type of curved arrow marks cannot exist. Okay, so this is your fixed support. This will exert three reactions. Now, this is what is the types of supports you have studied. Next, second point is this I remove. Now, you must also know about a second point about the external indeterminacy. The reactions here are two reactions VA-HA, VB-HB. So, now we will see the second point, note 2. External indeterminacy, DSE. DSE is nothing but R minus S. What external indeterminacy means is, it is the number of reactions in excess of equilibrium equations. So, R means total number of unknown reactions. In this problem, you have 4: VA, HA, VB, HB. Number of equations of equilibrium available. Total number of equilibrium equations available are only 3: sigma x0, sigma y0, sigma m0. So, now in this case, external indeterminacy DSE is equal to R minus S. 4 minus 3, you will say that 1 degree. Now, what is this indeterminacy, or why the 3 reactions, a minimum number of reactions required are 3 is like this. Again, this part about the stability of a structure we will discuss in detail for beams, frames, trusses, etc. Now, in this case, when for any structure, for a plane structure to be in stable condition, minimum number of reactions must be 3: horizontal, vertical and moment reaction. Why 3 reactions are required? Is corresponding to 3 equations of equilibrium, we require a minimum of 3 reactions, otherwise it will not be in stable condition. On a big structure, let us assume that 10 forces are acting from right to left. At least one force in the form of a reaction must exist to make sigma x 0 to happen. So, one horizontal reaction is required. Supposing that 10 forces are acting vertically down, at least one force must act upward to make sigma y 0 to happen. That means vertical reaction is required to keep it in equilibrium in the vertical direction. On a structure, assume that 10 moments are acting clockwise. At least one moment must be there in the anti-clockwise direction to make sigma m is equal to 0 to happen. Okay. So, for sigma m 0, one more reaction is required, 3 reactions. So, corresponding to 3 equations of equilibrium, you require a minimum of 3 reactions. Any reaction extra you provide, you cannot find using equations of equilibrium, that is only redundant. That means unnecessarily you are providing more reactions than required. In this case, if you provide say 4 reactions, then 4 reactions you cannot find using equations of equilibrium. How many such reactions you cannot find using equations of equilibrium is called external indeterminacy. External indeterminacy means how many reactions are there in excess of equilibrium equations. So many equations, so many reactions you cannot find from the equations of equilibrium. When we say DSE, external indeterminacy is 1 degree, not that angular measurement, 1 degree we call it. That means there is one reaction in excess of equilibrium equation which you cannot find. Okay. So, this is how external indeterminacy is found. That means this truss is externally indeterminate to 1 degree. One reaction is there in excess of equations of equilibrium. Okay. So, this is about the external indeterminacy is 1. That is why this is analysis of statically indeterminate trusses. So, it is a statically indeterminate truss. How we should manage problems? Now, how to find, even if it is externally indeterminate truss, by inspection how you find the forces in the members. Such simple questions only they can ask you in the 2 marks segment. Okay, say like this. Now you see, as I told you in the earlier, how the pin connections are hinge support. There is a hinge support here, hinge support here. Hinge support means there are 2 triangular plates, one pin is there. Because of this triangular plate fixed in position here, that pin cannot move horizontally, cannot move vertically. Here also this pin cannot move up, cannot move horizontally. That means those 2 pins are fixed in position. Within those 2 pins you have a member. This member cannot deform, it cannot elongate. For it to elongate, it must break the pins, then it move away. The pins are sufficiently strong. So, because of the 2 pin supports, member cannot elongate or contract. That means deformations are 0. If deformation is 0, force in the member is also 0. So, that is your third point. In 2 minutes time, you must detect whether it is a 0 force or not. This much story you do not have to explain. If you see the member, can it elongate or contract, you see how the support conditions are. Directly we can tell that force in that member is 0. So, due to hinge supports at A and B, member AB cannot elongate or contract. Since deformation is 0, force in the member AB is also 0. Now, this problem is similar to this hall, let us say. Assume that you are sitting here and there are two walls here. These two walls are sufficiently strong. Now, from outside, two JCBs from that side and that side with heavy force they are hitting the wall. As long as walls are not broken, we will not be stressed at all. Whatever push is there, those walls will take and they stop it. You are free from any stress. This situation is also same. Those two pins are so strong that they don't go in or out. Then whatever is there between the pins, it will not be loaded. If at all pin moves right side or up, then it has to be pulled. Without pulling this member, it cannot go up. That means then force will develop in the members. In this case, since they cannot move up or because of the hinge supports, they don't move up or down. That means AB cannot elongate or contract, so FAB must be 0. Now, fourth point is like this. Supposing that this member AB is subjected to temperature changes. Suppose without this, only this member AB you are heating it, say. If the pins are not there, it could have elongated, but now pins are not permitting. So they are fixed in position, it wants to elongate, pins are pressing it. Then it will be under compression. So due to temperature changes, AB member you can stress it, but otherwise due to applied loads it will not be loaded. This again same situation here. From outside the wall, and whatever amount of force you apply, you will not be loaded. If someone comes through the door and they apply some temperature, so then we will be heated. Same situation here also. Due to temperature changes, there will be forces in the member AB. Otherwise, due to applied load, it cannot be stressed. Okay. Supposing this is the point here. If member AB is subjected to a temperature change, then force will be developed in the member AB. This what you have studied, again strength of materials you have studied. If both ends are fixed, let us say, then due to temperature increase, stress is alpha TE, force is stress into area alpha TE into A. Same thing here also. Force in the member AB is equal to stress into area, temperature stress into area. So temperature stress we know alpha TE into A. Now this becomes like a strength of materials problem. Force in member AB is so much. It can be tensile or compressive depending on if you are heating it, say, then compressive stress. If temperature decreases there, then tensile stress will develop in the member AB. Okay. How numerical question can come is like this. In this case, actually by inspection itself FAB is 0, but once they have given you for 2 marks, so it will be over in 10-15 seconds time itself. That's all. Just will detect that it cannot elongate or contract, it is 0. Solution is over. Now I am discussing the structural behavior of such trusses. Okay. Supposing that in this problem, if alpha is equal to 10 into 10 to the power of minus 6 mm per degree centigrade and subjected to a temperature rise of 100 degrees centigrade and axial rigidity is 10 to the power of 6 Newton. Then force in AB. Now force will develop. So force in the member AB is alpha T AE. I can put it as like this. AE or EA same. AE stands for axial rigidity. So instead of giving cross sectional area and Young's modulus, product can be directly given under the heading axial rigidity. Its units are force units. As I told earlier, axial rigidity is the force required to produce unit displacement in a unit length of a member. So alpha is 10 into 10 to the power of minus 6. Temperature is 100 degrees centigrade. Axial rigidity is 10 to the power of 6 Newton. So you will get around 1000 Newton. In other words, 1 kilonewton. They will ask you whether tension or compressive. Because it is temperature rise, there is a compressive force. So 1 kilonewton compressive is one of the options. Like that. Okay. Next. So now fifth conclusion we can write from this one. In any statically indeterminate structure, due to temperature change, sinking of support, yielding of support, fabrication errors, these four actions may produce some forces in the structure or may develop stresses in some part of the structure or entire structure, depending on the configuration of the structure and the configuration of the reaction supports. So, in a statically indeterminate structure, due to temperature change or due to sinking of supports, or yielding of supports, or due to fabrication errors, forces are developed in some part of the structure or entire structure. It can develop sometimes if the supports are such that it may not develop for certain type of loading only, but it will develop some forces are developed in some part of the structure or entire structure. Then you have to physically see, first of all you have to see whether it is statically indeterminate structure or not. Then for that particular variation, sinking of support or the temperature changes, how to find those forces. In this case, finding the magnitude of the forces is a 20 marks question. Whether force will develop or not, or compressive or tensile force will develop is a 2 marks question. You have to detect what type of force is developed. Like as we have told you, force in the member AB. So it is 0 in this case. So finding that is 0 easy for us. Such simple question where you have to think maybe say 15 or 20 seconds time. Such questions they can ask you in the third topic. Okay. So may or may not develop in some part of this structure or entire structure, the stresses will develop. Now I have completely given you the structural behavior. Similar examples let us see now. Force in the member AB. This point let us say A, B, C, D, E. This force let us say 20 kilonewton. Here you are applying say 40 kilonewton. This angle of inclination may be 30 degrees and this is say 60 degrees. Like that they have asked a question, let us say. This is like a wall, this is like a ground. Once they put like this hash line means it means that that pin cannot move away or in, up or down. That movements are prevented for C, B, A pins. Okay. Now in this case you see at A this pin cannot displace, it cannot move right or left, up or down. At B also it cannot move up or down, right or left. Here what happens is here this pin is fixed to the ground. This pin is sufficiently long to accommodate 4 members. This is the pin, let us say. One member went this way, another member went up, another member went inclined direction, another member went like this. That means this pin must be sufficiently long to accommodate 4 members. And at the ends it is fixed to the ground so that this pin cannot go down. Whatever load you apply on the pin, that force is directly transferred to the ground through that pin because pin is resting on the ground and ground is holding it. So, load coming onto the pin is resisted by the ground only. You pull it or push it, ground only will resist. Okay. So, 40 here, 40 this member will take, this member will push the pin. Then pin will in turn transfer load to the ground only. It cannot transfer to the other members because they are independent. One member is like this, side to that one more member has gone. If the pin goes down, only then other member will be pulled. Otherwise no choice at all, no chance at all. This member also will be under compression only if the pin comes down. If the pin doesn't come down due to some reason, then this will not be stressed. Okay. So like that. So AB member now, since same logic we can use it, force in the member AB is 0. By inspection you should, this you should not take more than say 10 or 15 seconds time. Then another 1 hour, 1 minute 40 seconds etc. you must use it for some other problems. So is the case with AC member. BC member cannot elongate or contract. Then what is the third member? You see at E, 3 members are meeting, at E 3 members are there. This you can visualize as if it is a member whose force is 20. So 1, 2, 3, 2 are in line, third must be 0. So in this case total number of force members having 0 force are 3. Like that they can ask what is the force in a particular member or how many 0 force members are there. Any which way they can ask. So FAB is 0, FBC is 0, FBE is also 0. All different reasons. This reason is 3 members, 2 are collinear, third member has to be 0. This one, since it could not elongate or contract, it is 0. So 3 member forces are 0. Okay, next one. Supposing that if they ask you a question like this, say, number of members having 0 force are see here one, there is a force P here another force P here, like this. Say A, B, C, D. Length of the members are, let us say, some L and L. Okay. It is a statically indeterminate structure, but you can still find the reactions because of the configuration. In this case, you see how many members have 0 force. So it's a 2 marks question once given in GATE. All complete structural behavior, you should have an idea to answer this question within your stipulated 1.5 minute time. Now at B you have know 1, 2, 3, 2 are in line, third must be 0. Here 1, 2, 3, 2 are in line, third must be 0. Then the third one is AC member. Because of the two hinge supports, A and C cannot go in or out. So you cannot elongate this member. So 3 members have 0 force. And with that, options didn't end here itself. And how 3 members are 0 force, 2 members are compression, and 3 members 0 force, 2 members are under tension. Like that they ask, which means that we must know how to find forces in other 2 members also. Now it's just by inspection. Arrow is going left side, to balance it this arrow must be right side. Because the arrow is away from the joint, this also should be away from the joint. P. Come here, right side arrow, to balance it left side arrow. Now arrow mark is away from the joint, it should be away from the joint. So 3 members have 0 force and 2 members are under tension. So one of the options is this one. So this is the scope. Okay, now what are the support reactions then? See here, P is acting left side, to balance it HC must be right side, its value is P. Because this is 0, VC must be 0. They can ask what is the vertical reaction at C also. Here, P is acting right side, so HA must be left side. This is 0, so VA must be 0. Like this. So, member forces you will find like this. Next, let us see how to find horizontal thrust. Find horizontal thrust at the supports. Till now they didn't ask you only this point, so it is likely that this year they may ask this question. This point is A, B, this is C, loading is W, 60 degrees, 60 degrees. Okay. Now there are 4 reactions as we have learnt: VA, HA, VB and HB. He is asking what is the horizontal thrust, means what is the value of HA and HB. Let us see. It's a 2 marks question. Such cases, to find horizontal thrust, without finding force in the member AB, you cannot find the thrust because it is statically indeterminate. Once you know force in one member, it becomes a determinate. So by inspection, you can find that AB member has no choice, it has to be 0. Now because of the symmetry of the structure, symmetry of loading, supports will share the load equally. So VA must be W by 2, VB must be W by 2. Having found this one, this arrow is upward, to balance it, it has to be downward. This is force in the member BC. Same is the case here because of the symmetry, force in the member AB. We'll see how much it is directly. Force in the member BC we want to find, say, how much it is. I can write sigma y0. If you write sigma y0, upward positive, downward negative, this we are writing at B. Okay, plus W by 2 minus FBC sine 60 must be 0. So FBC you will get W by 2 sine 60, that means W by root 3 compression, because arrow is towards the joint. So this is W by root 3. If arrow is towards the joint, here it should be towards. Because of symmetry, this also must be same, W by root 3, W by root 3. Now you can use sigma x0. If you write sigma x is equal to 0, if it say right side force positive, left side force is negative. So minus HB plus FBC cos 60. See, FBC is acting like the downward, down to the right. So right side forces means positive. FBC cos 60, its value is W by root 3. Must be 0. So HB you will get W by 2 root 3 kilonewton or whatever it is. So one of the options is W by 2 root 3. So this HB you will get W by 2 root 3. Here also this is W by 2 root 3. Now it looks as if AB member is subjected to a compressive force of W by 2 root 3. But that is not the case. It is 0 only. This W by 2 root 3 force is not acting on this member. It is the force exerted by the triangular plate on the pin. Why triangular plate will exert on the pin? Because this member is pushing the pin. So to keep the pin in equilibrium, these two reactions are exerted by the triangular plate on the pin. So if you see the free body diagram of the pin, how it should be in equilibrium, cut all this, pluck it out, draw that free body diagram. Free body diagram of bolt at B. So this is the bolt, cross section of the bolt I am showing. Length is sufficiently long to accommodate these two members. Okay. Now this is the bolt at B. What free body diagram means, it is the diagram of a body on which what others are doing you have to show. What are the other people? On the pin, pin is resting on the triangular plates. Then what triangular plate is doing on the pin? On the pin, triangular plate will exert VB, HB. This force is W by 2 root 3. This is W by 2. Then on the pin, what inclined member will do? This is force in the member BC, W by root 3. Okay. So on the bolt B, three forces are acting. Under the action of these three forces, pin is in equilibrium. Then what is this force? This is 0 only. So VB and HB are exerted by triangular plate. Triangular plate on the bolt. That's why I have given you the free body diagram. Means how the hinge supports, how roller support, how fixed supports look like. Who is on whom the pin is resting and how the members are attached to the pin. You must have a clear picture to understand this type of free body diagrams or to understand this type of questions. Why the force in the member AB should be 0, why it cannot elongate or contract, how connection is made, you should have a clear picture. Okay. So now I think from this free body diagram you will know that AB is not subjected to any compression. B and A are in equilibrium by themselves. Without this FAB force, these three are in equilibrium by themselves. This simply keeps quiet. AB member keeps quiet. Now, let us see one more. This is about the indeterminate trusses. These indeterminate trusses are subjected to temperature changes also, or there can be lack of it. Then, how the forces will develop? That we will see in the note 6. Next topic we will see like this. Forces in the statically indeterminate trusses due to lack of fit or temperature change. Okay, now how the construction will go, let us see. Assume that you have built a truss like this. This point, let us say A, B, C, D. Earlier in the statically determinate truss means only this triangle I have shown. If BD member has some lack of fit, then simply you will pull it and bolt it because B is not fixed in position. So now you fixed it. You added one more BC and CD members also you added. Now it is determinate. Now you thought that you want to add one counter bracing member. Means you want to make the structure as indeterminate structure. So this is say 2 meters again or 1 meter, 1 meter. Then diagonal length is root 2 meters. That means what? 1414 mm. This he cut it properly, so no issue was there, but this he could not cut it properly. Instead of 1414 mm, he cut it 1400 mm itself. 14 mm short was there. That means when you tried to put this one, it came up to here only. Let us say C dash. So this much error was there. This is delta. Some delta was the lack of it. This much lack of fit was. That means the member is too short by an amount of delta. This is member AC dash before connecting to truss. This is the situation. Now what we have to do, I have to attach it. If I simply pull it and keep it up to here and bolt it means not possible because I have already bolted here. Then you can ask the truss to come here. This C will not come here because already members are there. It is now a stable condition, it is there, it will not come down so easily. So this fellow says I cannot go here. C dash says I cannot go to C. Both of them are fixed in position. Then what we have to do? We have to connect it. We have no choice. Now we hold C dash, pull it. You must pull it to such an extent that C dash matches to C. Then once two holes match, then insert the bolt and tighten the nut. In the process, AC member, what you are doing? Pulling it. So AC member is under tension. So with so much tension, you have to pull it. Once you bolt and remove your fingers, then whatever tension was there, then some part of the tension is transferred to these members in the form of compression. Otherwise, joint will not be in equilibrium. Assume that we didn't understand what I talked. What I am now with the help of diagram we will see. Now I am holding, pulling it, it's under tension, bolted it. Now that situation I will represent it here. This member I pulled it and kept in position. This point let us say A, B, C, this is say D. This truss is externally determinate but internally indeterminate. Blue color member is extra. So what we have done was member AC dash is pulled and kept in position in the truss. So pulled means it is under tension. So some tension T was there, let us say. Arrow mark must be away from the joint. Tension means. For this tension to exist, sigma x0, if I write the x component of T is T cos theta, someone should take. Then who will take that? The T cos theta is balanced by this member like this. This is under compression. T sin theta or whatever is there is downward, so it has to be balanced by this one. This is also under compression. Without these members under compression, this cannot be under tension because you are removing it and observing it. Such type of problems you have solved in strength of materials. What where you have done, a copper tube is there. Inside you kept a steel rod, two rigid washers. Tighten the nut. When you are tightening the nut, once you remove your hands, so once you tighten the nut means the copper tube is under compression. Who will give that compression? Rod only should give. We are not compressing with any force. So compressive force is given by the rod only. In the process, rod is under tension, tube is under compression. So if you take the free body diagram of the joint at one end, washer end, then tensile force, compressive force, they must balance. Otherwise, washer will not be in equilibrium. So for it to be in equilibrium, tube will be under compression, rod will be under tension to keep simply in equilibrium condition. Similarly, here also when you tensile force up, pull it and bolt it and remove your fingers, then these are not moving anywhere else. That means it is still in equilibrium. Maybe after deformation, instead of this position somewhere here, they will compromise and settle down somewhere here in between. How much it settles down? That is a 20 marks question. So how much contraction takes place? What is the final position? Is a 20 compatibility conditions you have to write. Now in this case, assume that this has slightly come down. Somewhere here they will settle. This settling position is somewhere here. This red color one is after pulling it, it will take somewhere here. They take up this position. This fellow says it can go here. This fellow says it can't come here. Then what to do? Both of them must come to compromise. They will settle somewhere here. This will go up to here, this will come here. In the process, these two are under compression, this will be under tension. That tension I have depicted here. See, slight compression was there because of that. How much it comes down? 20 marks questions we will see. Compatibility conditions we will write and find the member forces. To write the compatibility condition and find the member forces, it takes a minimum of 7 to 8 minutes time. So such long questions are for 20 marks. Now you will be asked only this much. If a rod is member AC is too short in a statically indeterminate truss and pulled and kept in position, what is the force in the member BC? Tension, compression, no force, like that. That's all. Then in 2 minutes time, you should quickly draw this free body diagram and check what type of force will develop so that the joint will be in equilibrium. So now it's like this. Now see here, this is C towards the joint, so it must be towards the joint, towards the joint, towards the joint. Here also T cos theta going right side, so it should be left side, compression. Towards the joint, towards the joint. T sin theta going up, so it should be down. Towards the joint here, towards the joint. Now we see towards, away. Towards, away. Tension, tension. That means in one of the papers they have asked this question. In a statical indeterminate stress diagram also they have given, member AC is subject is a too short by an amount of delta. It is pulled and kept in position. What is the force in the diagonal BD? So since you pull this diagonal, naturally this diagonal will also be in the same force and peripheral members are all under compression. Then what about the support reactions? They simply keep quiet. Is there any external load? No external load, no external reaction. So the three reactions here will be 0. VA 0, HA 0, VD is also 0. Now we completely the truss is in equilibrium within themselves. Like bolt and copper tube and steel rod problem, you tighten the nut and keep it on the table. It will remain on the table only. That means they are in equilibrium by themselves. How? Compressive force in the copper tube must be equal to tensile force in the steel rod. That's what you have studied. Same concept as I took it and attached it here. So forces are developed in all members of the truss like this. Any one member they will ask. That is due to lack of fit. In another paper they asked like this. Truss they have given. Member AC is subjected to a temperature fall. Then what is the force in the diagonal BD? If it is subjected to temperature fall and these truss members are not there, temperature fall means it will contract. First permit the contraction to happen. So delta alpha TL or L alpha TL is the contraction. Now that contraction is not permitted, who will stop? These four members only. How? By pulling it. So member AC is first under tension because you subjected it to temperature fall. So it is a tensile stress will develop. So put first tension. Then to keep it in equilibrium, how the other forces are developed. You have 2 minutes time to draw this free body diagram. That's all. But how much is the compression or how much is the tension is a 20 marks question. Now you see. Let us see all this discussion will write in the form of points. First observation is whether it is determinate or indeterminate. Externally, three reactions are there, three equations of equilibrium. DSE R minus S 3 minus 3 0. Externally it is determinate, but internally it is indeterminate. How we find is like this. Note 1. Internal indeterminacy. This internal indeterminacy you call it as DSI. Internal indeterminacy means in the beginning I told you in the trusses chapter how many for a perfect stable truss M must be equal to 2j minus 3. If at all number of members are more than 2j minus 3, we call it as redundant truss or internally indeterminate truss. How much indeterminacy is there is this one. That means how many members are there in excess of 2j minus 3. So many members you cannot find using equations of equilibrium. So DSI means how many members are there in excess of 2j minus 3. So internal indeterminacy means this one. It is the number of members in excess of 2j minus 3. In this case, how many members are there? Peripheral 4, diagonals 2, 6. Number of joints are 4. So DSI you will get M minus 2j minus 3. So 6 minus 2 into 4 minus 3, you will get 1 degree. So it is internally indeterminate to 1 degree. That is the first observation. Second one is, because of lack of fit, what type of stress will develop? Now, if the member AC is too short or subjected to temperature fall, you have to pull, keep it in position. So it is under tension, and from the joint equilibrium, other member forces you have to find. Means just put the arrow marks, that's all. Arrow blue is going left side, then red must be right side. Otherwise, sigma x0 will not happen. So we will write the second point. If the member AC is too short or subjected to a temperature fall, comma, then it must be pulled and kept in position. Kept in position. So tensile force is developed. So tensile force is developed in AC. First this one. Tensile force is developed in AC. Now to to keep the joints in equilibrium, to keep the joints in equilibrium, forces are developed in all other members. All other members of the truss, as shown in figure. That much only is the scope for 2 marks. How much is the force is a 20 marks question, because you take minimum of 5 to 6 minutes time. 5 to 6 minutes time taking for a question in the exam is too much of a time. Is a 20 marks question. Next, let us see third point. If at all, this is a statically indeterminate structure. If you change the dimension, change the cross sectional property of the member, that means cross sectional area, you increase or decrease, then they change in the cross sectional area, that means change in the axial rigidity of a member, influences the forces in the members of the truss also. This is what you have studied in strength of materials. In any statically determinate structure, the reactions are independent of cross sectional area and material property. But if you have a statically indeterminate structure, then the cross sectional area, material property influence the magnitude of reactions. First chapter, simple stress and strains, that's what you have studied. What you have studied, let us see in the third point. This I remove. See, not 3. You have a statically determinate structure. You are applying load W, cross sectional area A, Young's modulus is say E, A, B. That means its axial rigidity AE, flexural rigidity EI say. Now what are the reactions? VA is equal to W, MA is equal to W into L, and horizontal reaction is 0. Supposing that I double the cross sectional area, I also double the flexural rigidity. Let us see how what happens. W. Now this beam has 2 AE. Axial rigidity is 2 AE. Flexural rigidity is say 2 EI. Then what are the support reactions? VA again W only. HA is 0 only. And MA is equal to W into L only. That means the material property, cross-sectional property will not influence the magnitude of support reactions in a statically determinate structure. This is your conclusion. This is what you have learned. In a statically determinate structure, but deflections may be more or less, but the reactions are same. In a statically determinate structure, the cross-sectional property and material property will not influence the reactions. That means reactions are independent of material property. Then after this we have studied the indeterminate structure. This is 3A, let us say 3B. What you have learned was this one. You apply load P. This is a AE. This is a 2AE. This point let us say A, B, some point say C. Length is say L by 2. L by 2. Now you see, if the cross sectional area this and this are same, then here HA and HB is a 0.5 P, 0.5 P. But if this is 2AE and AE, this will be more than 0.5 P. So you have calculated, assume that approximately say 0.7 P. If this is 0.7 P, this will be how much? 0.3 P. If it is same, then 0.5, 0.5. Now reactions changed. So H and HB magnitudes will depend on the material properties and cross-sectional properties. Okay. So in a statically indeterminate structure, in this case what happened, if this is, supposing that this bar is there like this, say P you apply, this length is L by 2, this length is L by 2, axial rigidity AE, axial rigidity AE. For this case you have studied already. What is horizontal reaction? Because lengths are same, HA you will get 0.5 P, HB is 0.5 P. That means it depends on the relative stiffnesses of the members. Now this P is shared by these two members equally because these two members axial rigidity is same. Here in this case what happens, your P will be shared by the two members 0.5, 0.5 because both the members are equally strong. In this case this is 2AE, this is AE, one member is strong, one member is weak. So when you apply load P, stronger member will take more load, weak member takes less load. That means reaction they are more than 0.5 P, less than 0.5 P. So the stronger the member, the more is its share. Then who will decide? As you have learned, AE by L. axial stiffness decides who is strong axially, who is weak axially. Now, in supposing that in a room two members are there, let us say, if two members are equally strong and you give them 10 rupees, both will share 5 rupees, like this. If one fellow is very strong, one fellow is weak, then 10 rupees, strong fellow will take 7 rupees, he will give only 3 rupees to weak fellow. Who will decide that 7 or 3? Their muscle strength. Here, axial stiffness. That will decide who should take more, who should take less. The way we behave, structures also behave in the same way. So, like this, that means the material property influences the magnitude of the reactions or magnitude of the forces in the members. So, this we write as another conclusion. So, I think this conclusion you can write here. In a statically indeterminate structure, the material and cross-sectional properties influence member forces and support reactions. This is what we have learned in SM, that we are writing as a generalized statement. Now you see, this is AE, this is 2AE. You doubled the axial rigidity, but the force is not doubled. 0.5 P, it is slightly increased to 0.7 P, but it did not become P. Linear variation won't be there. This is doubled, so this also will not be doubled. Slightly it will increase. Okay. So is the case in the indeterminate trusses. If axial rigidity of a one member is doubled, then force in that particular member slightly increases but not doubled. Just because you doubled axial rigidity, already existing 10 kilonewton is there. So then it won't become 20, 10 may become 13, like that. So that we'll write in the fourth conclusion. This I remove. So based on this observation, that you can extend it to any members. So whatever we have studied in strength of materials, that general observation we apply here. So note third point, in a statically indeterminate truss, if cross-sectional area of a member is doubled, then force in that member slightly increases but not doubled. Okay, it should be indeterminate truss. If it is a determinate one, whether the axial rigidity doubled or halved, it has no influence on the member force.